Okay, so our first topic today is software security and static analysis, and why software security is related to the software quality engineering. So in of this course, okay. Uh, so first let's have a look at what is software security, right? So basically, I software security I is a quality that controls the ability of the system to ensure that users or other systems can access its data according to their level of authorization. Just remember that it is about users can access the system's data according to their level of authorization. For example, if you are admin, right, you have the access uh, to almost everything, right? But if you are a guest or like a regular user, so you don't have the access to change some configurations. You can only get the information related to yourself. Okay, that is, but access the data according to the level of authorization. Okay, this is security. So security about this factor, quality factor, we have several at least uh, sub factors. The first one is a confidentiality, right? Confidentiality, which is about the system ensures that data is accessible only to those with appropriate access, right? For example, your password is only available to yourself. It's confidential to yourself. That's a confidentiality. Okay. Second one is a integrity. The system doesn't allow changes without authority to data or software programs. For example, this software, so we have, so for Moodle, right, the university admin, they have the access to change the layout, right? They change how a Moodle site looks like. Okay, but as a regular user, we don't have this. We cannot change it, right? We cannot change it. That's integrity. So it doesn't allow changes without authority to data or software programs. Third one is non-repudiation. What does it mean? Uh, if something, if actions or events can be proven to happen, we cannot deny it, right? So if a user can access this system, has a right to access the system, we cannot deny it. That's a non-repudiation. And also, next one is a reliability or liability or responsibility. That doesn't mean so the actions of an entity can only be related to that entity. So if this is about responsibility, so if you, so for example, one user, right? So one user, so the actions of this user can only be related to this user, right? And and this user is responsible for the action related to this user. This is liability responsibility. And also the next one, authenticity, right? So it's about a the possibility to prove that the identity of a subject or resource is the one that is claimed, right? So we need to authenticate that the identity of a subject or resource is the one that is claimed. So these are some sub-factors of software security. Software security have different levels. The first level is software itself, right? For example, the data of the software, like OpenMRS, like the information of the users, right? So it's about software data and the control and access, right? So how who can control which part, who can access which part, and also next level is authentication of the host. The host machine would grant access to some users, but not to other users, right? So they need to use a username password to give their right level of access. Okay, this is about host host level, and also infrastructure level, network encryption, firewall. So these things are protecting the software and its environment. It's another level of security. So we need to guarantee that the security is assured at different levels. Okay. And normally, if there's vulnerabilities at lower level, the higher levels are vulnerable too, right? Okay. So this is about the security and security levels. So how can we ensure that software security is reliable, right? So what is software security assurance? First, like other quality controls, quality assurance, security must be ensured in all phases of development. So we need to do security assurance activities during development, and during the design during the requirements, also testing, right? So the sooner a defect is identified, the least expensive it is. Okay. So we need to verify security for our software, right? And the software we developed for another company, and also external software that we will use in our system. Okay. So in detail, or like more specifically, the software security assurance is protecting the software against known vulnerabilities and against unattended malicious actions. What is the known vulnerabilities? So we know if you write this software in this way, it's vulnerable, so other people can attack your system. There's known vulnerabilities. Unintended malicious actions. That is the action of other people, unauthorized people, to access your data and code. If your software is vulnerable, then others are easier to attack your system, right? And so what is the process to ensure software security, right? What is the process of a software security assurance? We need to do software security assurance activities throughout the software development lifecycle. Okay. The first step is to establish software security requirements, right? The second is to establish requirements for software development, operation, and maintenance process. So first step is to establish some overall security requirements. Second step is to establish requirements for different stages, right? For example, for software development stage, you need to ensure that the number of vulnerabilities that are exposed in your code should be lower than a threshold, right? Third step is to perform frequent assessment of security requirements. What are assessments techniques? For example, run static analysis. So we will talk about static analysis later, or run penetration testing. So two typical techniques to ensure that the system is secure. And also we need to perform reviews, inspections for security requirements. Yeah. Lastly, we need to integrate the software security assurance activities to our configuration management process, like integrate it into continuous integration or continuous deployment, right? So when you write a code, when you push a code to the central repository, so you want to run a static analysis, for example, to ensure that there's no severe security vulnerabilities. Okay, so that is basically what the activities are, what we need to do during software security assurance, and what is the process. Okay, so next, so I will talk about vulnerabilities, right? So what is security vulnerabilities? So vulnerability is a weakness in design, and also it is a weakness in, it can be a weakness in implementation, operation, or internal control. Vulnerability is about the weakness of the system. So if you have a weakness in your system, or if you have a vulnerability in your system, others can attack your system. Others can take advantages of that vulnerability or weakness, right? Um, so vulnerability becomes a problem if it becomes a point of an attack or an exploit. If you have a vulnerability in your code and no one exploit, no one attack this point, it's fine. But if someone attack it, so there's a problem, right? So vulnerability basically provides the opportunity for others to attack your system. So vulnerabilities and exploits can result in loss of money, private data, or even life. Okay. So how can we prevent vulnerabilities? Or how can we identify or detect vulnerabilities? So basically, we can use a code inspection or static analysis to identify vulnerabilities. We can also use a penetration testing to identify vulnerabilities, or use code reviews and inspections. Okay, so three basic ways, right? Static analysis, testing, and code reviews. Okay, so here we have some examples of the biggest data breaches of the 21st century, right? So here we can see, here it shows the loss of money, right? For example, in 2013, so one data breach of in Yahoo, right, cost 3 billion loss of US dollars. So that's very expensive. So why there are vulnerabilities in the source code, in the code, or not just code, maybe in your configuration as well? So there are different reasons or causes. The first one, old unpatched vulnerabilities. One vulnerability can be identified, described, but the developers don't want to correct it immediately. They just expose in the source code because it might be possible that vulnerability will not be leveraged by others, but it is also possible the other way, right? This is the first cause, because developers are usually very busy working on the features of the system. They may ignore some vulnerabilities. The second is human errors. Human errors is about the developers, they don't know there's a vulnerability, but in fact there is. So their code might be vulnerable, but they haven't recognized it, right? Or like a malware. So malware is other people, they develop software and also they use those software to affect your system, to cause damage to your system, right? That's malware. And insider abuse is the most dangerous vulnerabilities. So it requires internal security measures. For example, someone in a banking system, some developer can put someone working for a banking system can put a vulnerability in a code, and then this vulnerability may be exploited by himself or other people. There are some examples about this, right? Okay, the physical theft This is another cause of vulnerability. Our phones, our laptops might be physically theft by other people. Right? So these are causes of vulnerabilities. And what are the vulnerabilities? So what are the top 10 vulnerabilities? So here we have an organization which is called OWASP. So this is a open source fund. This is a nonprofit foundation for secure software. So it defines the top 10 vulnerabilities. So we'll go through these vulnerabilities, and just to get, you don't have to understand each of them. We just need to get a sense of what are the vulnerabilities. Okay, the first one is SQL injection. So what is SQL injection? So basically, so people can access your database, right? You control what type of data each level of users can access. For example, admin can access uh, more advanced data, more complete data, and the normal users can access part of data, right? But sometimes people may take advantage of this SQL access to get access to the data that they are not entitled to do, right? For example, I so people may add something to the secret commands, and it is very hard to identify. But these secret commands can get access without notification, without your notification. You can get access to the unauthorized information. For example, here, in the login page, we have a username field and another password field, right? And we can insert the username, right, and a password, something. Or if we use a SQL, like a SQL language, a SQL command, right, SQL statement. So we use a select something from users. So we map a username and password, right? However, here we see this OR or 1 equals to 1, right? So this is very dangerous because this action would return the first account in a database. Even though the username is not the first account, but here if you put this one, it actually will return the first account in a database. Sometimes it's the administrator's account. So it is possible for the attacker to obtain access to all the data, right? They input something. Actually, they just input their username and a password, but they add more information. And this more information will be mistakenly granted by the security check, right? They thought the password is the password and or 1 equals 1. They thought this is the entire password, but in fact it is not. Only the password part is a password, or 1 equals 1 will actually return the first account, right? So this is about SQL injection. People add additional information to the valid fields like username or password, but they put more information to get more they put more text to get more information. It's about SQL injection. It's very dangerous. Okay, the second one is cross-site scripting. This is basically like attacker want to attack, want to get information of a user, right? That they both access the same database, but the attacker add something, an extra information in their request. And this request are not, um, this request actually are accepted by the server, but actually within this request, there are some script to store the information of others. Okay. Yeah, it typically, so when the input fields and URLs are not controlled, right? So normally we need to check the input fields and URLs to make sure that they are secure. But if it is not controlled, right? And also when the application has scripts that can run on the client instead of a server, right? So then, so one user can put some information, can send a request to a server, and this one will get downloaded by the victim, and when this part of code is running on the victim's machine, so will damage the information, will give access of information to the attacker. So that's cross-site scripting. Okay, this is another injection. So we can see the common thing between these two, right? So they are quite similar actually. They are basically doing a request either through database or through like HTTP request, a RESTful request. They add more information than they are required to, right? And this extra information would do the malfunction to either get a access to the information that they are not authorized to, or just like access the victim's information. Okay. It's top two. Okay. Third one is a broken authorization and a session management. So sometimes we store information in a UIO, right? For example, we may store password, we may store session ID, right, in a URL. If this URL is accessed by other people, right, other people might change some part, right? For example, they just change the destination. Here in this example, they just change the destination. They change the destination to a mile to a mile drive, right? Then this active session would be exposed, and the information will be stored in a mile drive, right? So well, if we want to have secure code, we need to make sure this doesn't happen. We need to make sure that you cannot change this destination. Okay, this is a broken authorization and a session management. Next one is a direct object references. For example, a user is accessing a web server, right? And they are sending a request to a web server, and they have done the authorization, everything, authentication. They put their username and password, and everything is done, and then they need to do some action. And one of them is to specify his own user ID and to do something, right? But what if this guy changed the user ID to a different user ID, right? It may get information from another people for another people. So we need to make sure that the user ID is only associated with the one accessing the system. We need to do this check, right? But sometimes if you don't do this check, and if you just make your database open, that's very dangerous. Okay, this is insecure direct object references. The next one is also about URL, is a failure to restrict URL access. It's basically here the same thing, just change the user. You change the, for example, they change from the user to admin to get more information. So if we want to make sure it's secure, we need to check the privilege of this user. We need to make sure that it doesn't access the information at a different level, okay? The next one, unvalidated redirects and forwards, right? Like sometimes so when we access a website, it may redirect us to a different website, right? And what if they just change their URL? They change the URL to redirect to evil site, right? So it's in this case, it can be very dangerous. So we need to make sure that the redirected URL is valid and also it's safe. Okay. These are the 10 top vulnerabilities. So I don't need you to know all the details at this moment. You just want to give a sense what is a vulnerability, how people can exploit the vulnerability in the system. Okay, and also so when you are actually working on security and you find a vulnerability, you know where to find the references, right? Okay. So how can we find these vulnerabilities? So basically, we use a static analysis. We use static analysis to scan the code to find whether the patterns, for example, this pattern happen, right? So next topic is a static analysis of this software, okay? So static analysis is code scanning before deployment and executing to find the vulnerabilities. Also can find other bugs as well, but the most important to find vulnerabilities or weakness. So we can identify vulnerabilities during the coding stage. So different static analysis techniques are a data flow analysis, control flow graph analysis, and also tender analysis. What is data flow analysis? Basically, it analyzes the source code to understand how the data flows through the code, right? For example, so you have a password input and how the password flows through the source code. From this analysis, they know that whether your password is changed, for example. And a control flow graph is similar to data flow graph, but it's about control, like how the execution of the system follow the path. For example, first execute this method, then execute another method, then execute a if branch, then one exception. That's a control flow graph. Trend analysis is to identify variables polluted by users. So what does it mean, right? If a variable is modified or changed by users, then it might be vulnerable because some people, like hackers, they may take advantage of this to modify your system and cause damage to your system, right? So what we can do, right? So we can monitor each input variable. We can monitor each other possibility that other people can change the variable. For example, username, password, configuration, a URL, right? All the user input, we track them and we know like how they change other variables in a system. So then we can track all the variables to avoid the attacks, okay? So there are some advantages and disadvantages of security, of a static analysis. Uh, so we can run at the same time or run multiple software at the same time, right? And also can be repeated the time to time. Right? It's very easy to run it. And it can facilitate developed method like continuous integration, continuous deployment, because it's very fast. And after we commit the code, we can just run the static analysis, run scanning, and make sure it's safe. Um, so some vulnerabilities are very easy to detect, very helpful. For example, this top 10 might be famous, and there are sophisticated tools to detect them, okay? But there are also some disadvantages. The first one, some types of vulnerabilities are very hard to detect, right? And a very typical disadvantage of static analysis tools is lots of false positives. So we'll talk about false positive later, okay? And also there are some configuration problems which are not be able to detect it by static analysis, because static analysis only look at code, right? And also it's hard to confirm that the security problem is really a vulnerability, right? Because we need to, after they give our some example, some explanation, it's still very hard to understand it, okay? And also when you do static analysis, you need to compile it, and sometimes maybe challenging, and it may prevent the static analysis. Um, yeah. Okay. So we talk about these advantages and disadvantages, right? And the limitations we talk about briefly mentioned. The first one is false positives, and the second one is false negatives. What is false positives? It is not a vulnerability, but your tool tell me it's a vulnerability as a false positive. Okay. And the false positive of static analysis tools are usually very high, like as high as 80%, 50%. That's very common. So they report, for example, they report 10 vulnerabilities, but if you carefully examine it, you can only find 5 of them actually are vulnerabilities, false positives. And false negatives, a vulnerability exists, but it was not detected by the tool, right? For example, this tool may not be able to detect this pattern, okay? And this is also very common, and the false negative rate is also very high. And even it's very hard to measure what is a false negative, because we don't know how many vulnerabilities are in source code, right? We can only see those obvious ones. So how to select tools, right? We need to use static analysis tools to analyze our code. First one, language, right? Like your Java, C++, Python use different tools. And what types of vulnerabilities are you mostly interested, right? And these are the criteria that you need to consider when you select your tool, right? So then we will do a tutorial. So we will do an exercise actually. I want to do it in the class, and if we have any problems, we can discuss. Okay. A tutorial is a tutorial for static analysis, and it's if you go to Moodle, so there's a file called tutorial for static analysis. You just follow the instructions, and it's very easy. And I'll add a break here, and also I'll give you what's the time? I'll give you 30 minutes to do this, also including a break, 30 minutes. So I'll see you at 2:10, right? I'll see you at 2:10 after 30 minutes. So let's discuss the tutorial results, and let's continue with our lecture. Okay. So this is not the end of the lecture, it's just a break, right? So, and you do your exercise 30 minutes, including a break. And if you have any problems, you can post your questions on Slack. We can discuss anytime. Okay. Okay. So I'll see you later.